This video is for Math 1001. It is for Unit 2 on compound interest. This comes from section 7.4. Compound interest is a little different from simple interest, which we talked about previously. When interest is computed on the principal and any previously earned interest, we call this compound interest. Notice that this is different from simple interest. Simple interest only calculated interest on the principal. Now we're basically counting interest on interest as well. Let's go through a few words and vocabulary that goes along with compound interest. Many of these you'll notice are going to be similar to what we did with simple interest. First of all, A is the future value, just like in simple interest. And just like in the simple interest, it is the principal plus the interest. It's just now we don't calculate them quite the same way. P, again, is our principal. That's what we start with. That's the amount that is put in the account to begin with. R, just like before, is the yearly interest rate. And just like before, we'll express it as a decimal. So we'll usually be given a percentage, but we'll change it to a decimal. N, this is new. This is new for compound interest. This was not part of the simple interest definition. This is the number of times per year that the interest is compounded. And we'll talk about some words that come up here. So let's kind of come to the side for a second. So interest can be compounded annually. That means one time a year. So that is an n equals 1. It could be semi-annually. Semi-annually is twice a year. So here, n would equal 2. We could say something like quarterly. Quarterly would be 4 times per year, so n would be 4. We could say monthly. That would be an n of 12. We could say daily, an n of 365. So those are kind of some common ones that come up for our n value. And then T is our term of investment or our time, and it's in years as well. Okay, so let's do some examples using compound interest. Notice we have our formula appear at the top. A equals P times 1 plus R over N to the NT power. All right, so let's do an example. Okay, so in order to pay for college, the parents of a small child, they invest $20,000 in a savings bond that pays 8% interest compounded monthly. We want to find the future amount of the investment after 16 years. So let's go through and figure out what all these stand for. So we invest $20,000. This tells me that P is $20,000. That's my principal. It pays 8% interest, so that's my rate, and we'll convert it to a decimal, so 0.08. It's compounded monthly. Remember the number of times you compound per year, that's our n value, so this tells me n is 12. It says find the future amount, that's the future value. That says A is what we're looking for. And it says after 16 years. That tells me that my time or term is 16. So those are all my pieces. Let's write out my formula. So it was A equals P times 1 plus R over N to the NT power. So A I don't know, so I'm just going to leave it as an A. My principal I can plug in is 20,000. 1 is always a 1 plus R, so 0.08 over N, which is 12, to the N times T power, so 12 times 16. And now the easiest thing to do here is if you have a TI-84 calculator, to use the fraction notation and try to type it in exactly as you see it. Instead of doing a lot of little pieces at once and rounding as you go, your answer is more accurate if you type it in all at once. If you need any help with that, please let me know and I'm happy to help. But once we type that in, this ends up being $71,627.89. Okay. All right, So let's do our next problem. Okay, so it says to pay for new machinery in 8 years. So let's highlight as we go. In 8 years, a company invests $10,000 at 7.5% compounded quarterly. How much money will be available in 8 years? Well, the 8 years we've already looked at. So let's go through and write what each of these stands for. So 8 years, this is my T value. So T equals 8. We invest $10,000. So that's my principal. That's what we're starting with. At 7.5%, that tells me my rate would be 0.075. So 7.5% would be 0.075 as a decimal. Compounded quarterly, that's 4 times per year, so N is 4. And it says how much money will be available in 8 years. That's the future value, so that it's asking for A. So my formula is A equals P 1 plus R over N to the NT. A, I don't know. That's what I'm looking for. My principal is 10,000. 1 plus my rate, I found to be 0.075, over my N is 4, to the NT is 4 times 8. And again, if you can put this in your calculator where it looks just like this in your TI-84 using your fractions, that is super helpful. And it'll make your number come out a little bit nicer. Fewer steps also. We get that to end up being $18,120.24. Part C. How much would you have to invest in a 5-year certificate? So how much would you have to invest in a 5-year certificate of deposit, paying 2.3% compounded weekly to make it worth $4,500 at the end? So let's go through and see what we have. So how much would you have to invest? Now we don't know the principal. That's asking for the principal, how much to invest. A 5-year certificate tells me that T is 5. Paying 2.3%, that says that my rate is 0.023 as a decimal. Compounded weekly, that tells me my N is 52 because there are 52 weeks in a year. To make it worth $4,500 at the end of the term, that means I want A to be $4,500. So this time I have A and I'm looking for P. All right, so my formula is A equals P times 1 plus R over N to the NT. And if I'm trying to find I'm trying to find P. I want P by itself. What I'm going to do is I'm going to solve for P by just dividing both sides by all of that other stuff. So now we see these two will cancel out. And I have that P is the same thing as A over 1 plus R over N to the NT. And now I have P by itself, and that's what I'm looking for. So P equals A, which is 4,500, over 1 plus R over N, so 0.023 over N, which is 52, to the N times T, so 52 times 5. And if we put this in our calculator, we get $4,011.25.